Hello, and today this video assessment problem will be broken up into two parts. The first part will be showing how to find the g of x of the definite integral of x to 2 of f of t times d of t. The second part will show you how to find the derivative of h of x. Part A asks us to find g of x, which is equal to the definite integral of x to 2 of f of t times d of t. Now in this case, g of 2 would be equal to 0 since the distance between 2 to 2 is 0. First, I found g of 3. Since distance between 3 to 2 on the graph of f of t is actually negative, I found the area between 3 and 2 and I subtracted it from g of 2, in which I got my answer of g of 3 to equal to negative 1.73. To find g of 4, I then found the distance between 4 and 3 on f of t, and since it is above the x-axis, I added that to the value of g of 3, so that my new value for g of 4 was 0.78. I added the values of the areas between each points for g of 5, g of 6, and g of 7 as well, since they are also above the x-axis, meaning that their values would be positive for the area. Next, for g of 8, since it is below the x-axis on the original function of f of t, I found the distance between 7 and 8 and then subtracted it from g of 7, in which my new value was negative 0.64. I repeated this process again for g of 9. However, for g of 1, even though it is below the x-axis, it is increasing from 1 to 2, and my new function of g of x is shown in red. For part B, I used the fundamental theorem of calculus part 2. The fundamental theorem of calculus part 2 states that if g of x is equal to the definite integral from x to a of f of t times d of t, where a is a constant and f is continuous around a, then g prime of x is equal to f of x. Relating this problem of FTC back to part B of this problem, we see that h of x is equal to the definite integral from 3x minus 5 to 2 of f of t times d of t. Since 2 is a constant and the graph of f of x is continuous around 2, FTC 2 proves true, in which this case h prime of x is equal to f of 3x minus 5 times 3. Now, when we plug in 3 for x, we get the equation equal to f of 3 times 3 minus 5 times 3. When we simplify this out, we get f of 4 times 3, in which f of 4, going back to the graph, is equal to 1, so that h prime of 3 is equal to 1 times 3, or 3.